Chapter 4, so this is dealing with a lot of graphs and equations, which we will get into. But to begin with, we're just going to be looking at graphs and what the graph is saying, being able to identify what the variables are, and being able to basically put into words what the graph means. Okay, so we're going to start with this one. And this graph is an air in a balloon. So you're blowing up just a regular balloon. And think about the volume of air in it. So just think about how much air, that's what volume is measuring, how much air is in the balloon and over time. So we're blowing it up and eventually it's going to pop. Okay? So there are a couple of questions that we have. First off, what are the variables? The variables are almost always going to be what the x and the y axis, so this is your x and this is your y, what those labels are. So our labels are the volume of air in the balloon and the amount of time it takes to blow up the balloon. So the variables are volume and time. Then it asks you, describe how the variables are related at various points on the graph. Now what you have to understand is this is something that's not necessarily like just here's the right answer and this is the only way that it can be worded. These answers can be worded in different ways, but that doesn't mean that anything is correct. It does have to really accurately depict what the picture is showing. So what is this showing? Well, what it's showing is that each time you blow, okay, you're blowing for whatever amount of time, a few seconds, the volume in the balloon increases. Okay? Then what does this part show? Well, if you think about blowing air into a balloon, you have to take some time to get the air back in your lungs. And so for a certain amount of time, the volume stays the same. The air inside the balloon doesn't go up or down. Then you get your breath and you blow again, and the air in the balloon is going up. And then while you're catching your breath, the air in the balloon stays the same. And then you blow again, and the air goes up. And then you catch your breath. And then you blow again. And why does it take a drastic shot down? Well, because the balloon blew up, and now all the volume in the balloon left. And so it goes straight down to zero because it goes really quickly. So this is in the middle of the fourth blow. So here's your first blow, second, third, and in the middle of this fourth one, the balloon pops. And so this is an explanation of what's going on the graph. Okay? So here are two more. So first off, what are the variables in each graph? So the variables in the first graph are time and length of your board. Okay, so your variables are time and length. And then describe how the variables are related at various points in the graph. Okay, so what I would say is, what's happening right here? Why does the board length stay the same and then all of a sudden the board length goes down? Well, if you think what happened in order for the board length to get shorter, you were cutting it. So describe how the variables are related at different points. The length of the board gets smaller once it is cut and stays the same for an amount of time while it is being cut. So your board, it's being cut, it's staying the same, and then all of a sudden the cut happens and it drops. Board stays the same, you cut it, it drops. stays the same, stays the same, stays the same. Cut it, it drops, and then the board stays the same for the duration of the graph. For this one, what are your variables? Your variables are cost and minutes of calls. And what is this graph showing? This graph is showing that the cost of your bill stays the same right here, staying the same until you reach your minutes limit. Something to that effect. The cost of your bill stayed the same, stayed the same, stayed the same, and then at this point, however many minutes you get on your plan, now all of a sudden you start getting charged extra per minute and it starts to go up. And that's what that graph is showing. Okay, so this problem is, so we want to be able to match a table and a graph. Kind of, if you're given a table, be able to show like which graph goes with it. Okay, and so here's what this happened, or what's going on in this problem. A band allowed fans to download its new music video from its website. The table shows the total number, so this is very important, the total number of downloads after 1 day, 2 days, 3 days, and 4 days. Which graph could represent the data shown? So sometimes it's easiest to eliminate one of them if you can. All right? And so if you look at this one immediately, as the days go on, the total downloads goes down. Well, that's not possible. How can the total number of people who have downloaded it go down? It's not like you can undownload something and just give it back. Once you download it, you can delete it from your computer, but the download is already done. So this one immediately we know is out. Okay. The next thing is, does it increase at a constant rate, or does it kind of go kind of slow and then fast, or fast and then kind of taper out? And one way to do that is find out what's the difference between these numbers. So if we take 1011 and subtract 346, we get 665. What that means is the first day there were 346 downloads, the second day there were 665. So 665 plus 346 from the day before gives us 1011. Okay, how many downloads were there the third day? So we started with 1011. We ended up with 3,455 minus 1,011, and we end up with 2,444 downloads. That's the third day. And the fourth day, 10,426 minus 3,455 gives us 6,971. So what we see happening is the first day, 346, the next day it almost doubled, the next day it almost quadrupled, and the next day it almost tripled. So it's getting more popular. Okay, so it's not constant. This is out because this is a constant change. So did it start high and then kind of taper off, or did it start low and then go really big? This one is the one, B, the one that shows it, and not C. Starts, here's 346, then a few more, 665, then it starts to get bigger quicker, and then even bigger yet, and that's why B is the correct one. So that's just kind of one way to kind of look and see, how to tell the difference between, what they're showing on the table and what they're showing in a graph, is sometimes the differences help. But you can also think about it as, if you were to graph these points, day 1, here would be day 1, day 2, day 3, day 4, and then here would be the different scales that you would have to make. All right, so that's the gist of what's going on in this section.